Okay, guys, I want to continue on with looking at chemical compounds. Yesterday, you learned how to count atoms. So first of all, the chemical compound tells us two things about that substance. So here's hydrogen peroxide. The chemical compound is H2O2. Basically, that's the ingredients. So it tells us two things. First of all, it tells us what elements it's made up of. So we count the capital letters. We have two capital letters, means we have two separate elements. This little subscript tells us how many atoms we have. So we have 2 atoms of hydrogen and 2 atoms of oxygen in the chemical compound for hydrogen peroxide. If we look at the chemical compound for sugar, we have 3 capital letters. So we have carbon, hydrogen, and oxygen. And again, the subscript tells us how many atoms there are. Baking soda. I want to take a moment and look at this one. Again, we have 1, 2, 3, 4 capital letters, so we have 4 elements total. That N and A goes together. If there's a lowercase letter, it belongs to a capital. So if we look at this, Na, sodium, does not have a subscript, so it's a 1. Neither does hydrogen. It's a 1. Carbon, 1. Oxygen has 3. Now they can ask you a variety of questions. They could ask you how many atoms there are per element. They could ask you how many total elements do you have. There's 1, 2, 3, 4 elements. They could ask you how many atoms you have total. 1, 2, 3, 4, 5, 6. But what do we do if we see something like this? Okay, we're used to seeing this, but we have a large number out front. What does that mean? Okay, that large number out front is called a coefficient. So this number 2 is a coefficient. Okay, this part right here looks familiar. We've done this. So what you're going to do, so the only thing that the coefficient does is it tells you how many molecules you have. So you have H2S, you have 2 of them. Okay, so all you're going to do is multiply the coefficient by the subscript. So we're going to identify the elements. That's step 1 always. We have hydrogen. We also have sulfur. We have 2 hydrogen and we have 1 sulfur. Because we have 2 of these, now we have to multiply this by 2. Again, that coefficient tells us how many we have. So we actually have 4 atoms of hydrogen and 2 atoms of sulfur. So if we look at this image, this kind of helps us out. All right, so we have the compound BW2. So we have 1 B, okay, and then 2 W's. So the model looks like this, 1 B, 2 W's. But because we have the coefficient of 3, we actually have 3 of these molecules then. Okay, so how many B's should we have? 1, 2, 3. How many W's? 1, 2, 3, 4, 5, 6. So if we actually write this out according to what we do, okay, we focus on this first. You write what elements you have. I have B and I have W. There is no subscript. That's a 1 and that's a 2. And then I multiply by the coefficient. That gives us 3 B's and that gives us 6 W's. So let's try this out. So the first question says, how many molecules are in this formula? Okay, well, the coefficient tells us that we have 2 molecules of this. So how many elements? Well, we've only got 1, and that is hydrogen. How many total atoms? Well, let's figure this out. How many subscripts? 2. What do I do with the coefficient? I multiply. So I actually have a total of 4 atoms of hydrogen. If we look at this one, let's identify what we have. You'll notice that we have 2 capital letters, which means we have 2 elements, K for potassium and I for iodine. There is no subscript, so therefore it's 1 atom of each. But how many molecules do we have? 3. So what do? We multiply both of these by 3. 1 times 3 gives us 3 potassium. 1 times 3 gives us 3 iodine. This one might look a little bit intimidating. Just again, focus on what you know that you need to do. Identify your elements, Ag, N, and O. We have 2 Ag, 1 N, 3 O's, and then you multiply it by the coefficient times 4. Okay? In the next video, we're going to add parentheses, but it's all just the same thing, step by step.